Okay, now let's come to the second section of this lecture. We'll talk about the IoT reference model. So this picture is actually from the previous video. So it shows the reference model. Basically, a reference model describes what are there in the system and how they are associated with each other. So for the reference model in IoT, there are 4 sub-models we would like to describe. So we have the IoT domain model, IoT information model, IoT functional model, and IoT communication model. A domain model describes the main concept of specific areas of interest, in this case, the IoT. Basically, it describes what entities are involved in IoT solutions. So if it is a domain model in the cars, in the vehicles, so maybe I guess the main concepts include the engine, include the electrical control, includes the steering system, those kind of things. But for IoT, we have other concepts, of course, right? So the domain model captures the basic attributes of main concepts and the relationship between these concepts, serve as a tool for human communication between people within the domain in question and between people in other domains. Basically, by looking at the domain model, you and I, which are not very familiar with this field, can also understand what's happening there. So for the domain model, we will use the unified modeling language class diagrams to represent the relationship between the main concepts in the IoT domain model. So the UML, Unified Modeling Language. So actually it's very straightforward. It basically uses some simple diagrams to indicate the relationship. For example, by using an arrow, it indicates it is a relationship, and this shows aggregation, and this association. Composition means that class B is part of class A, and also direct association, realization. Yeah, most of the time we'll see some real life more specific examples later, but this picture just gives you some taste of the UML class diagram. For the relationship we describe here, you can read the following slides to better understand this relationship. For example, altogether we have this kind of relationship, the generalizations, realization. For each relationship, actually we have some description of them. So interested students may look into that composition relationship, but to be honest, so terms are quite straightforward themselves. Realization and association, they should be straightforward. With the relationship we define here, so let's look into a real-life example. The IoT is a support infrastructure for enable objects and places in the physical world to have a corresponding representation in the digital world. The purpose why we want to represent the physical world in the digital world is to remotely monitor and interact with the physical world using software. So let's look at an example now. So you may have seen such scenarios nowadays. So it is we can call it a smart parking lot. So basically there are 16 slots in the parking lot, and each slot here have a sensor to indicate whether that slot has been taken by a vehicle. And we also have a payment station, and there is a availability sign which can be viewed in the street. Basically, it shows how many empty slots are there. And also, in this example, registered users can also use a mobile app to know how many slots are empty using their mobile app. So that's actually happening nowadays. And also, it is a very straightforward example. So this paragraph describes what I described just now, basically the layout, the setup, and the functioning of this scenario. With that in mind, now let's look at the major concepts in this domain model. As interaction with the physical world is key for IoT, it needs to be captured in the domain model. So the most fundamental interaction is between a human and the physical world, right? So a user and a physical entity are 2 concepts that belong to the domain model. basically for IoT solution, we need to have users, right? The users can be human users, and also it can be an application. For the physical entity, so basically it can be a building. In this case, it is a parking lot, and it may contain other physical entities. For example, a building is made out of several floors, and several floors can have some rooms. Basically, users and physical entities are two concepts in the IoT domain model. And also, we need to have the virtual entity. It is the representation of physical entity in the digital world. So if we go back to the example here, so in the physical world, we have a slot, right? So in the digital world, it may be just a storage space in the computer, indicating whether this slot is empty. So that's the virtual entity. So actually for virtual entity, it can be many things. It can be a database entry, it can be a geography model, and it can be an image or avatar, or it can be digital artifacts. Yeah, you can read this into more detail. One thing I would like to highlight here is that the digital artifact. So a digital artifact is an artificial of digital world that can passive or active. So it can be a database entry, or it can be an application software. Basically, it is because for the database, it is created by human, right? So it is artifact. For the application software, it is also created by human beings and in the virtual world. So it is also digital artifact. Okay, so in that case, virtual entity is another main concept in the domain model. And with these entities, we actually have many interactions. Human to machine, application to machine, machine to machine interaction, something like that. And also, for the IoT domain model, we will have device. So device, we have sensors, straightforward. We have actuators because we need to monitor and control the real world. Monitor is achieved by sensors, and control is done by actuators. So for the parking lot example, just the sign, the availability sign is actually the actuator. Basically, it displays the information, right? So that people can take actions. And one more type of device is the tags. So some of you may have taken the RFID course. Basically, those, that's one example of the tags. And also, you have the QR codes and those kind of, and also beacons, those things. So that's another example. So for the parking lot example, so it may have LED light, it may have buzzer, and something like that. So I will list this for you to read about. Okay, another concept in the domain model is the resources. There are what I highlighted here. There are software components that provide the data for and are endpoints for controlling physical entities. So it can be on device resources or network resources. On device resources, for example, you may have some storage space in the sensor or in the sensor node. So that's the on-device resource. And also the network resource are those resources that are available on the web. For example, the cloud storage, the maybe Google Drive, something like that. And resources can be of several types. Okay, well, the last concept we would like to introduce for the domain model is the services. So basically, resources is both functionality as services, because resources, most of the time, they are in the form of data. Basically, we want to use the data to do something, right? Maybe it is used for monitoring, it is used for control. And when we use this as a functionality, then it is considered to be services. So usually they have open and standardized interfaces. And services are therefore digital artifacts with which users interact with physical entities through virtual entities. So those are the main concepts for the IoT domain model. If we go to the illustration, so you see that, okay, we're the human user, and can be human user, right? And then the resources, So resources can be different kind of resources, but generally resource. And we have virtual entity, and we have artifacts, and the resources usually is both the functionality as service, and we have the physical entity and augmented entity. Basically, you install sensors to the physical object, so it is augmented entities. And for the device, we have the sensor, tag, and actuator. So basically, this figure, it is a illustration of domain model. This figure covers the main concepts we mentioned just now. Okay, so that's a general figure, general illustration. So let's come back to the parking lot example. So this is the domain model for the parking lot example. Okay, first of all, we have the physical entity. Basically, it is an occupation sign. So remember that sign shows how many slots are available. We also have the parking spot from 1 to 8. Basically, it is in one row, and the other part is one row. And for each parking spot, it's physical object, right? We need to have a virtual entity to represent it. So that's what we have here. Okay, for the physical entity, we have the sensor to it. No problem. And the sensor compose the sensor node. Basically, for the sensor node, we have 8 sensors. And the sensor node will create, so this is still hardware. And then it will correspond to the on-device resources. Basically, for each sensor, it has some storage space indicating the status of the parking lot, of the parking spot. So it corresponds to the resource. And for the resource, it needs to be used as a service, right? So we have the service. So the upper section of the figure here, basically it is a repetition of the information down there. Because we have 2 rows of parking spots, we just illustrate one of them into more details. The one on top is the same. And let's come back to the left-hand side. So of the occupation side as the physical entity, and basically it is a actuator because it displays the information, right? So you have the device to display, and it is connected to it is associated with the resource, and the resource will go to the service. And once again, the physical entity will be in the digital world. It will have a virtual entity, and it is associated with the resources and services for the physical object. So that's how we build. So from this figure, first of all, we know that we can find the main concepts, right? Basically, we know what are there. And also, we can also find out how they are associated with each other, right? So we can see the relationship here. Associated with is attached to, and something like that. So basically, it describes how the components are put together. So this sentence, this paragraph, and the following paragraph describe what's happening there. Describe what I mentioned just now into more details. Yeah, feel free to read that. Okay, that's for the IoT domain model. And then, as mentioned, there are many information there, right? That's why we also need to have an information model to further describe the situation. The virtual entity in the domain model is the thing in the Internet of Things. So the IoT information model captures the details of virtual entity-centric model. So let's see. Once again, we use the unified modeling language diagram to illustrate. For example, so yeah, just an illustration here. So for example, the resource description is both, the resource is both service, right? And the service is associated with the virtual entity. So, yeah, something like that. And you don't. And also, if we go to the parking lot example, so we can see that how they work here. So for example, parking spot number 1 is a virtual entity. It is related to the virtual entity of the information model. And also information model association is an instance of the information model service description, something like that. And this figure shows how the IoT domain model and IoT information model associated with each other. Basically, for the IoT domain model, it defines the main concepts. And then for the information model, it will, well, for each concept, it will bring in the information and the data. For example, for the virtual entity, it is further separated into the description attributes, value container, and metadata, something like that. Basically, in this information, this data are needed to describe a virtual entity. And for the functional model, which is also part of the reference model, it aims at describing function groups. And for the functional view of a reference architecture, it describes the functional components. So yeah, let me clarify here. For functional model, it is part of the domain model. It is part of the reference model. And for functional model, it describes the function groups. And for the functional view, it is part of the reference architecture. And for the functional view, it describes the functional components. Basically, for functional group, it has one or more functional components. Yeah, you'll get a clear view of this later. Okay, for the functional groups, it is shown in this figure. So we have 1, 2, 3, 4, 5, how many? 1, 2, 3, 5, 6, 7, 8, 9. 9 groups. Okay. Basically, it describes how the functions are working together to realize how the entities are organized. Okay, for the 9 groups, so the application, virtual entity, iOS, service, device functional groups are generated directly from the user, virtual entity, resource, services, and device classes from the IoT domain. Basically, they come from the main concepts in the IoT domain model, right? On top of that, we need to have the communication functional group, and also we need to have the server organization and IoT process management functional groups. Basically, some of them are directly from the domain model. Some of them are introduced here to fulfill the requirements, fulfill the functions. All the above-mentioned functional groups are needed to be supported by the functional and security functionality captured by the corresponding functional groups. So what it means here is that in addition to the 7 functional groups, we need to have dimensional functional groups and security functional groups to support the proper functioning of the system. Okay, for the detailed introduction of these functional groups, so I will leave it for you to read. So you don't need to just read through them. Don't need to look into detail. Just have an impression that okay, we have these functional groups in the functional model. So that's good enough. And one thing we like to mention here is that it's important to know that not all the functional groups are needed for a complete actual IoT system, because we're talking about the reference model here, right? We mentioned that reference model, it is the complete template, complete blue view for you to start with. But in your, basically it lists all the options you can have. But in reality, based on your applications, you can definitely simplify some of the functional groups if you don't need that. For example, if your application is quite simple, basically you don't need that. So it all depends on the actual system requirements. So in that case, we can say that the model is modular. Basically, you just pick whatever you need to use and put it into the architecture. So this figure shows how it is used in a modular way from a relatively simple model system to a more complex system. So these 2 slides describe how it is involved. These 2 slides describe what happened in this figure. So how we move from a simpler module, a simple system. Basically, we see that it only have at the beginning, it only have a few functional groups, and then we bring in other functions. The last model, we would like the last sub-model, I would say. The last submodel we would like to mention in the reference model is communication model. It consists of identification of endpoints of interactions, traffic patterns, and general properties of underlying technology used for enabling such interaction. In other words, it deals with the communication, right? The potential communication endpoints, including users, references, and devices, something like that. But just to put it simple, remember that the communication model deals with the communication of the different endpoints. So that should be good enough. So part of the, but remember, for the everything in the IoT, we need to also emphasize the safe, privacy, trust, and security. So in that case, sometimes we also include such a model so that every IoT system can work properly. Okay, so that's for the reference model.